Okay, so we are going to look at finding the concavity for this function here, which is f of x equals x squared plus 1 over x squared minus 4. So we need to first find the first derivative, and we're going to do that by using the quotient rule. So we're going to get Hody high, which is x squared minus 4 times 2x minus IDHO, which is x squared plus 1 times 2x all over x squared minus 4 squared. And we can simplify that. We can actually factor this down and get 2x times x squared minus 4 minus x squared plus 1 all over x squared minus 4 squared, which in turn, what happens here is these x squareds cancel. We get the minus 4, and this negative 1 here creates a minus 5. So we're going to get negative 10x over x squared minus 4 squared. So now we need to find our second derivative. We're going to do that in the same way. I'm going to give myself a little bit more room here. So we have Hody high, so which is going to be x squared minus 4 squared times negative 10 less high, negative 10x, times the derivative of the bottom, which is going to be 2 times x squared minus 4 times 2x. And that is divided by x squared minus 4 to the fourth. And so we continue, and this is negative 10 times x squared minus 4 squared. And then to simplify the rest of this, this becomes a positive 10x times 2 is positive 20x times 2x gives us positive 40x squared times x squared minus 4. So then we divide this by x squared minus 4 to the fourth. We can go ahead and we can cancel one of each of these. And so what we're left with is negative 10 times x squared minus 4 plus 40x squared over x squared minus 4 cubed. Which all in all, if we wanted to simplify this, 10 times the x, negative 10 times the x squared is negative 10x squared. We add that with the 40x squared, which makes 30x squared. And then the negative 10 times the negative 4 makes a positive 40. And we finally divide that by x squared minus 4 quantity cubed. So at this point, f double prime of x equals 30x squared plus 40 all over x squared minus 4 cubed. So we look at this, and we've got to find what kind of our critical numbers. And really, these, because they are the second derivative, we call them hypercriticals. Just to differentiate them between them. So our hyper ones work the same way, wherever our second derivative is 0 or undefined. So when we look at this question, 30x squared plus 40, when does that equal 0? Well, never. So there's no solution to this. And you can find this out on your own. And then you look at, well, x squared minus 4 cubed. Does that equal 0? Well, we can do the cube root of each side and get x squared minus 4 equals 0. We can get x squared equal 4, and x to be positive or negative 2. So these are our hypercritical numbers. So this is what we use for our baseline. So we've got negative 2 and 2. So we pick these different values for our hypercritical numbers to help. So we're going to do f double prime of, I don't know, negative 10, and f double prime of 0, and f double prime of 10, and figure out is it positive or negative. What's going to happen here? So if we plug in negative 10, our numerator over here is going to be positive because it's always positive. Our denominator, because negative 10 squared is large enough, it is going to be positive. So we have a positive number here. Again, our numerator is always positive. If we plug in 0, you can see down here, this will be negative 4 cubed, which is going to create a negative. And then finally, we have after, so if we plug in 10, we'll again get a positive. And so when we look at concave up, it's our positive areas. So we're going to have from negative infinity to negative 2, unioned with 2 to infinity. And we're going to be concave down when we are in between negative 2 and 2.